Hello, Joseph, and let me officially welcome you to the first edition of the Maintenance Analytics Summit here in Stockholm. We're very pleased to have you with us, so welcome again. And before we go on with further questions, can you please tell us more about yourself, your background?
Yeah. First of all, I'd like to thank you guys for inviting us over. It's really a momentous occasion to have this, and it's a great venue to advertise whatever we're working on. So a bit of background on myself. I'm a cryogenics engineer that accidentally stumbled on data science, right? So I'm part of the Lloyd's Register Marine and Offshore Innovation team. There's about 10 of us in the team. We're quite a small team, but where our role is really to look at on different technologies out there that could be a game changer for the marine and offshore industry. So there's quite a few, very, very relevant technology, and one of them is what we call health management, right? So health management is essentially the diagnostics and prognostics that people are talking about. So diagnostics is condition-based, right, as the term suggests, and prognostics is predictive, right?
Exactly. We'll get back to that. But first, Joseph, predictive maintenance is surely one of the most talked about topics lately when it comes to asset management, when it comes to maintenance as in general. So according to you, where do you see the biggest challenges when it comes to deploying data into bringing value to maintenance? What is stopping the companies from considering this approach? Because you would agree that some have not even started.
Yeah. Maintenance and reliability and maintenance engineers and technicians, they're a tribe, right? They're quite a tribe. There's a bit of tribal thing going on. They're experts. They really understand these machines, but there's no denying that failures do happen. Most of the time you're really doing over maintenance because you don't understand the health of this, right? So really to insert this technology, predictive maintenance, into a company, it requires the buy-in from ground level, and these are your maintenance engineers and technicians. So when you come up into the next tier, or the plant manager, right, you get a resounding voice that they appreciate this technology, right? If you don't address the right buyers, and in this case, at the end, it will be some financial guy. Right, the technology is not exactly cheap, right? So there's obviously going to be returns on the technology, and that's been proven in some early adopters like aerospace and power generation to some degree.
Yes, exactly.
But what you need is essentially continuous improvement, right? At the first application when you're trying it out, it could be like a cultural issue where the chief engineers or the maintenance managers think they know better than the analytics, so they tend to, deny or think otherwise or contest, rather than corroborate and work with the system, right?
So Joseph, now back to your presentation. Assurance of diagnostics and prognostics. Why this, and where are we today with it?
Yeah. So. In some mature industries that LR also has been working on, like defense, there's some maturity there and providing like a level playing field. It's essentially when we say in defense industry, when we say assurance, what we really want to do is, would this technology work? How good is good when it works, and what its limitations, right? Because a lot of the people that are buying or trying to understand the technology, they're not necessarily well informed, right? So LR being providing that certification or regulation of critical assets, mostly in marine and offshore, we've got a responsibility to make sure that any technology being adopted by our clients are integrated in a safe, responsible manner. So on the topic of diagnostics and prognostics, we want to make sure that repeatedly it does the correct fault detection. Repeatedly, consistently, it does diagnosis or articulation of those faults. Or even in some cases, it can really forward project or forward propagate the direction of those failure modes, which is essentially, prognostics. It's a little bit of semantics, right? Yeah. But, just being clear, people misconstrue early fault detection as predictive, right? But you're not really predicting the trajectory of the fault. You're just detecting it a lot earlier so you can respond in a better way. Right, so it's a bit of semantics, but hey, I'm not going to change those terminology.
As such, it's very important.
It is very, very important. Yeah, and this is something that, when we're going to be launching our new code, our rules, third quarter this year, and this terminology thing is something that we're putting out there so it's clear, right?
It's that's very nice to hear. People get used to hearing this stuff more and more.
Yeah.
Okay, so one of the main steps during your presentation in the LR approach that you described, you mentioned confidence in the analytics, development, and testing.
Yeah.
So, which sounds very nice, to be honest, and
yeah.
It's what the conference is about. Can you tell a bit more?
So, really, the best way to test if the analytics work is through life. Right? But we have a responsibility before you install it in any equipment, in any asset, you got to make sure that it does what it says it does, right? So confidence in the analytics, if it's taking it simply, if it's diagnostics, it means understanding the machine you're trying to monitor, understanding the components that make up the machine, right? Because it's one thing saying, oh, we think there's an anomaly in engine number 2. Right, but engine number 2 is made up of 500 parts, right? So detecting the anomaly early, it's helpful, but strictly speaking, it's not diagnostics, right? Because you gotta get down to a certain level of granularity, where the affected parts, because of that anomaly, is the one that you're describing, right? Or some people are calling it descriptive, right? Sorry, prescriptive analytics, right? To be able to get there. As I've said, you need to understand the machine, you need to understand the parts that made up the machine, you need to understand the failure modes that affect the parts of this machine, so then you're able to understand, do I have the right sensors? Right. So from having the right sensors, the sensors, again, they don't really, even not any sensor reveals the health, right? You need to make models.
What should you?
Yeah, you need models that abstract whatever the sensor is reading to indicate the health, right? So, the creation of those models, we're obviously very, very interested to say, yes, with this amount of modeling, with this amount of integration, we think there's confidence in detecting this type of failure mode repeatedly. And that's what we're trying to establish, right?
That's great, to be honest. So, Joseph, from your perspective, from your knowledge, for those organizations who are still struggling or have just started with this predictive maintenance journey, if you would suggest them one first thing that they should do, what would that be?
It's really understanding your business needs, right? I mean, there's a lot of great technology out there, but you could go round and round and say, oh, we just want to put this bolt-on technology, right? But if you're not specific on your need to measure certain failures, because it eats up your maintenance budget, you might be investing in the wrong thing, and you only realize it, halfway through the program, and you're going to say, well, this technology does not work, right? Yeah. No, but the technology does work, right? You're just using the technology not for the exact purpose of solving your specific business needs.
Understand your business.
Yes.
Okay, one final question, Joseph. What is the prediction about this topic in the near future?
Prediction of the predictive analytics.
Yes. If we're talking about it, we have some kind of.
Absolutely, I think it's showing value. You're obviously right now. There's a lot of interests right now. When we're talking to a few clients, everyone is saying, "Hey, could you do machine learning? Could you do artificial intelligence?" I think you got to realize that these are tools. Again, you got to align it to specific business problems. It's only when they start addressing specific business problems. We've had a client, I'm not going to mention who had specific repetitive failures, right? Of certain equipment, right? So if you're investing in alleviating that, then it really reflects well in saying, wow, this technology has value. Then that allows you to monitor all the other minor failures, or and that allows you to optimize your maintenance, right? So a lot of clients need to really be clear and articulate why they want to use the technology for the technology to become effective.
Joseph, let me thank you once again for being part of the Maintenance Analytics Summit and for accepting to conduct this interview. So thank you very much. It was a pleasure.
Thank you.